Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 2 Algebra. Topic Sequence and Series. Subtopic Sum to n terms of species and series. Summation of n square and summation of n cube. Infinite GP and its sum. One. Find the sum of parts n natural numbers. Let Sn equal to 1 plus 2 plus 3 plus n. This is an AP whose first term is 1 and common difference is 1. Using Sn equal to n by 2 times of twice a plus n minus 1 times of d, we get Sn equal to n by 2, 2 into 1 plus n minus 1 into 1. Simplifying, we get n plus 1 by 2. Implies summation of r from 1 to n is n plus 1 by 2. Remember this result. 2. Find the sum of the squares of the first n natural numbers. Let Sn denotes 1 square plus 2 square plus 3 square plus n square. We have r cube minus r minus 1 whole cube equal to thrice of r square minus thrice r plus 1. Remember this identity. Put r equal to 1, 2, 3 up to n, we get 1 cube minus 0 cube equal to 3 into 1 square minus 3 into 1 plus 1. When r is equal to 2, we get r 2 cube minus 1 cube equal to 3 into 2 square minus 3 into 2 plus 1. When r is 3, we get 3 cube minus 2 cube equal to 3 into 3 square minus 3 into 3 plus 1. So on. When r is n, we get n cube minus n minus 1 cube equal to 3 into n square minus thrice n plus 1. Adding vertically, we get cancelling the diagonally, we get this cancel up to this cancel. We are left with n cube minus 0 cube on left side, that is n cube only, equal to, we have to add this first column on first term on the right side, taking out 3, and the remaining one is n square plus 2 square plus 3 square plus up to n square, that is represented by Sn, minus, we have to take 3 common from the second term of right hand side, we get 3 times, so 1 plus 2 plus 3 up to n, and 1 is added n times, that is n into 1. Therefore, as 3 of thrice of Sn equal to n cube. Transfer this on this side, we get plus 3 times of sum of the parts n as a number is n plus 1 by 2. Transfer plus n on the left side, we get minus n. Taking out n from each term, we get this n times of this. Simplifying within bracket, we get this. Factorize numerator, we get these two products. And dividing 3 on this side, we get this, which is the sum of the squares of first n natural numbers, that is n plus 1 times of twice n plus 1 by 6, which is the sum of the squares of the first n natural numbers. 3. Find the sum of the cubes of the first n natural numbers. Let Sn denotes 1 cube plus 2 cube plus 3 cube plus plus n cube. We have r plus 1 whole power 4 minus r power 4 is 4r cube plus 6 of r square plus 4r plus 1. Remember this identity also. Put r equal to 1, 2, 3, n. We get, when r is equal to 1, we get this first row. We get, when r is equal to 2, we get this second row. When r is 3, we get this third row. When when r is equal to n, we get this last column. Adding vertically, adding both sides, we get cancelling this two term diagonally up. Lastly, we are left with this and with this, that is n plus 1 power 4 minus 1 power 4 equal to, first right side ki first term sing asidi ki 4 kamal lawthokhrabadi, we get 4 times, so 1 cube plus 2 cube plus 3 cube plus plus n cube. second right side ki second term dagi 6 kama lawthokhrabadi we get 6 times of 1 square plus 2 square plus 3 square plus dot plus n square, and third term dagi amuk 4 lawthokhrabadi 4 times of 1 plus 2 plus 3 plus dot plus n, and 1 see n times like 8 the n into 1, that is n. Putting which left side becomes this 1 power 4 is 1, which is equal to 4 times of Sn, because this is denoted by Sn. 6, which is the sum of the squares of first n natural numbers whose value is n times of n plus 1 times of twice n plus 1 by 6 plus 4 into this is also sum of the first n natural numbers, which is equal to n plus 1 by 2. Solving putting 4Sn on left hand side and others are transferred to left, we get this. Simplifying by expanding, we get this, and lastly we get Sn equal to n plus 1 by 2 whole square. This is the sum of the cubes of the first n natural numbers. Remember this result also. Exercise 9.4. Find the sum to n terms of each of the series in exercise 1 to 7. We have to find out its general term an, which denote an denotes its n term, and which is equal to in its term. First term is 1, for second term first factor is 2, for third term first factor is 3. Therefore for n term the first factor must be n, and the second factor is n plus 1. Multiplying n on n plus 1 we get n square plus n. Therefore Sn is summation of an. Put the value of an, that is n square plus n. Taking summation we get summation of n square plus summation of n. This represents sum of the squares of first n natural numbers, and this represents sum of the first n natural numbers. Their respective values are for first one this, for second one this. Taking common factor, for numerator we have to take n plus 1, and for denominator we have to take 6. Then first becomes twice n plus 1, for second term we have to write 3, and simplifying we get this, and taking out 2 and cancelling with 6 we get n plus 1 into n plus 2 by 3, which is the sum of the series. Question number 3. 3, 5, 7 they are in AP. Therefore an is twice n plus 1, and 1 square, 2 square, 3 square, that is n square. Multiply we get twice n cube plus n square. Therefore Sn is summation of an. An is 2 times of summation of n cube plus summation of n square. 2 into summation sum of the cubes of first n natural number whose value is n plus 1 by 2 whole square, and this is the what? This is the summation. This is the sum of the squares of first n natural numbers whose value is this. Taking common factor, that is n plus 1 by 6. For first one we have this, for second one we have this. Simplify and multiply we get this, which is the sum to first n terms of the series. Question number 4. Here an is 1 by n plus 1. We have to write this 1 by n minus 1 by n plus 1. Resolve. Therefore Sn is equal to summation of an, that is an is this, and taking n is 1 we get this, n is 2 we get this, n is n we get this. Cancelling second first, we are left with 1 minus of last term, that is 1 by n plus 1. Sum up we get n by n plus 1, which is the required sum. Question number 5. 5 square plus 6 square plus 7 square up to 20 square. Sn is this. Therefore its summation is from this is equal to sum of the squares of first 20 natural numbers minus sum of the squares of first 4 natural numbers, and whose value is n is replaced by 20. We get 20 plus 1, 2 times of 20 plus 1 by 6, whose value is exactly found out, and whose value is, after simplify we get 2840, which is the required sum. Number 6. Number 6, 3 into 8 plus 6 into 11 plus 9 into 14. We have an is thrice n plus 5. Multiply, we get this. Therefore, Sn equal to summation of an. An is 9n square plus 15n. Taking 9 times of summation of n square plus 15 times of summation of n, whose value, this is the sum of the squares of first n natural numbers. This is also sum of the first n natural numbers. And simplify, we get this, which is the required sum. Here an is 1 square plus 2 square plus 3 square plus n square, whose sum is n plus 1 into twice n plus 1 by 6. Therefore, Sn is summation of an. An is, we get this, and taking 1 by 6 common, 1 by 6 into 2 summation of n cube plus 3 by 6 summation of n square plus 1 by 6 times of summation of n. Put their respective values and simplify, we get this, which is the required sum. Find the sum to n terms of the series in exercise I to 10, whose n term is given by, n term is this. We are given n terms. Here an is this. Multiply on three terms, we get this. Taking summation, Sn is equal to summation of an, whose value is this. Taking summation in its term, we get this. Put their respective values. This is what sum of the cubes of first n natural numbers. This is also sum of the squares of first n natural numbers. This is sum of first n natural numbers. Taking common factor, that is n plus 1 by 2. For first, this, for second one, this, for third one, this, and simplify the term within bracket, and simplify, we get this, which is the required sum. Number 9. Here an is n square plus 2 power n. Therefore, Sn is summation of an, whose value is summation of n square plus summation of 2 square. First one is, the value of first one is this. For this, put n equal to 1, 2, 3 up to n, we get this, which is SGP. And whose sum is, applying sum to n terms of SGP, we get this. Simplify, we get this, which is the required sum. Here 10 an is this. Expand this, we get this. Taking summation on an, whose value is this, we get this, and put their respective values. Simplify, we get this, and taking n in from its term, we get this. Simplify, which is the required sum. Supplementary question. Find the sum to infinity in each of the following geometric progression. Question number 1. 1, 1 by 3, 1 by 9. Here a is 1, r is 1 by 3. We have to use S infinity, that is a by 1 minus r. A is the first term, r is the common ratio. In this case, r must be less, whose modulus must be less than or equal to 1. We have S infinity equal to a, whose value is 1, r, whose value is 1 by 3. Simplify, we get 1.5, which is the required sum. For question number 2, 6, 1.2, 24, etc. Here a is 6, r is 1.2 by 6, that is 0.2. Therefore, S infinity is a by 1 minus r. Putting their values, we get 7.5, which is the required sum. Find the sum to infinity in each of the following geometric progression. Question 3. 5, 20 by 7, it by 49, etc. Here a is 5, r is 4 by 7. How does r obtain? When this is divided by first term, we get 4 by 7. Use S infinity equal to a by 1 minus r. A is 5, r is 4 by 7. Solving 35 by 3, which is the required sum. Question number 4. Here a is minus 3 by 4. R is obtained when 3 by 16 is divided by minus 3 by 4. We get r is minus 1 by 4. You use S infinity equal to a by 1 minus r and put their respective values. We get 3 minus 3 by 5. Question number 5. Prove that 3 to the power half into 3 to the power 1 by 4 into 3 to the power 1 by r up to infinity is 3. one sum of 1 by 2 plus 1 by 4 plus 1 by up to infinity is, which is a geometric series of infinite. A is half, or common ratio is also half, we get 1. Therefore left hand side is this. Product of this term is 3 to the power half plus 1 by 4 plus 1 by I plus dot dot, whose value is 1. 3 to the power 1 is 3, which is right hand side, hence proof. Question number 6. Let x equal to 1 plus a square plus the up to infinity, and y equal to 1 plus b square plus up to infinity, where modulus of a is less than 1 and modulus of b is also less than 1. Prove that 1 plus ab plus a square b square plus up to infinity is equal to xy by x plus y minus 1. Here x becomes 1 by 1 minus as, and y is also 1 by 1 minus b. Therefore multiply, cross multiply, we get this which is also this, and solve a, we get this, and b this. Therefore product ab is, after giving their values, we get this, and 1 minus ab is what? 1 minus ab is, putting their respective values, solve, we get this. Thank you for watching video.